For centuries, humanity has gazed upon Mars, a beacon of possibility in the vast cosmic ocean. More than just a scientific curiosity, it represents a profound ambition to become a multiplanetary species. This aspiration, once confined to the realm of science fiction, is now being meticulously engineered by SpaceX. Their audacious goal is not merely to visit, but to build a permanent, self-sustaining city on Mars, securing the future of our civilization. It's a vision that demands unprecedented innovation and a complete rethinking of space travel. Central to this grand undertaking is Starship, SpaceX's fully reusable launch and landing system. Designed to transport both cargo and hundreds of people per flight, Starship is the indispensable artery connecting Earth to Mars. Its enormous payload capacity means it can carry everything from initial life support systems to heavy industrial equipment necessary for construction. Unlike traditional rockets, Starship is engineered for rapid reusability, drastically reducing the cost of space travel and making frequent missions to Mars economically viable. The initial phases of Martian colonization will be dominated by uncrewed Starship cargo missions. These critical flights will pre-position essential infrastructure before humans even set foot on the planet. Key cargo includes solar power arrays, construction equipment, robotic rovers for site preparation, and vital life support modules. These automated missions will also scout optimal landing zones, assess environmental conditions, and begin the intricate process of setting up communication networks and preliminary resource extraction sites. Each cargo ship is a step towards self-sufficiency. Once a robust cargo infrastructure is established, the first human crews will embark on their historic journey. Their immediate task will be to activate pre-positioned habitats, establish fully functional life support systems, and commence more complex operations. These early settlers will live in sealed, pressurized environments, initially perhaps inflatable modules that expand after landing. This phase is about establishing a secure, habitable base, refining resource utilization techniques, and preparing for the arrival of more settlers and more advanced equipment to expand the nascent outpost. Building a city on Mars is not without formidable challenges. The planet's thin atmosphere offers little protection from cosmic and solar radiation, necessitating robust shielding for habitats. Extreme temperature swings, frequent dust storms, and the absence of breathable air demand innovative engineering solutions. Life support systems must be incredibly reliable, creating a completely closed ecosystem where every resource is recycled. Overcoming these daunting environmental hurdles will be a continuous, evolving process, requiring constant adaptation and resilience from the Martian pioneers. A truly self-sustaining city cannot rely on constant resupply from Earth. In situ resource utilization, or ISRU, is therefore paramount. Mars is rich in frozen water ice, particularly at its poles and beneath the surface, which can be extracted for drinking water, oxygen, and rocket propellant. The Martian atmosphere, primarily carbon dioxide, can also be processed to create methane fuel using the Sabatier reaction. This ability to live off the land by converting local resources into usable materials is fundamental to long-term survival and expansion. With resources in hand, the next step is construction. Martian regolith, the loose rock and dust covering the surface, will become the primary building material. Advanced 3D printing technologies will be deployed to fabricate habitats, laboratories, and infrastructure directly from this local soil. This method minimizes the need to transport heavy construction materials from Earth, dramatically speeding up the building process. Future structures will likely be underground or covered with thick layers of regolith for radiation protection, forming an initial network of interconnected domes and tunnels. Beyond shelter, a Martian city requires a fully closed-loop ecosystem to sustain life. This involves sophisticated systems for air purification, water recycling, and waste management. Food production will rely on hydroponic or aeroponic farms housed within climate-controlled greenhouses, utilizing artificial light and recycled nutrients. As the city grows, these interconnected systems will become increasingly complex, mimicking Earth's natural cycles on a smaller, engineered scale. The goal is a delicate balance, where waste from one process becomes a resource for another, ensuring long-term viability. From the first uncrewed landings to the bustling activity of a growing city, SpaceX's plan for Mars is a testament to human ingenuity and perseverance. It envisions a future where Martian settlements expand, becoming centers for science, industry, and a new branch of human civilization. The challenges are immense, but the drive to explore and safeguard our species is a powerful motivator. A city on Mars would not only mark an unprecedented achievement for humanity but also establish a critical backup for life, ensuring our long-term survival among the stars.